For years, we've built AI agents like Swiss Army knives, cramming every capability into one giant prompt and hoping the model can juggle all of it at once. That era is ending. Welcome to the factory floor, where instead of one overloaded agent trying to do everything, you orchestrate a set of specialized units, each doing one job really well. This is the Vibe Coder's playbook for multi-agent systems, and over this video, we're covering 5 protocols that make it possible: MCP, A2A, A2UI, UCP, and AP2. Think of these as the wiring standards that let independent agent modules snap together into a clean assembly line, instead of a tangled mess of one-off custom code you have to write and maintain forever, block by block, integration by integration. Picture a single agent trying to do everything at once. Search the web, query your database, write code, and talk to customers, all from one context window. That's your single agent monolith, and it looks exactly like this block of tangled wires. Contextual overload, a search space too large for the model to reason through cleanly, and one crash away from taking your entire workflow down with it. Agentic microservices flip that model completely. Instead of one giant brain trying to hold everything, you get small specialist agents, like these A2A and A2UI nodes, cleanly wired to each other. It's the exact same lesson backend engineers already learned, moving from monolithic web apps to microservices. Specialization scales cleanly, and giant blobs of shared responsibility eventually don't. Here's the math that actually justifies this shift. If you wire every model directly to every tool with custom code, integration complexity grows as n times m. Add a few more models or tools to your stack, and suddenly you're maintaining 50 separate bespoke connections, where a single API change on one vendor's side snaps the whole loop. That's the bespoke trap most teams fall into. The Vibe Coder way inserts one middle layer, MCP, so complexity only grows as n plus m instead. Every model connects to MCP exactly once, and MCP connects to every tool exactly once. Stop handwriting fragile wrappers for every model-tool combination. Standardize that single connection point, and you can scale to any number of tools without rewriting your integration work each time. So what does that middle layer actually look like in practice? Think of MCP as a universal socket built right into your agent's harness. Plug a tool in, and your agent instantly understands its data schema and exact capabilities. No custom glue code required on your end. MCP gives you 2 ways to make that connection. STDIO is the local option, zero network setup, running as a background process over standard input and output, which makes it ideal for rapid prototyping right on your own machine. SSE over HTTP is the remote option instead. It connects out to endpoints across the web, with a smaller footprint and real-time streaming built in. Same universal socket either way, you just pick local or remote depending on where the tool actually lives. Now let's compare the old integration grind to the Vibe Coder workflow across 3 stages. For discovery, the old way means hunting through scattered API docs and handwriting custom REST wrappers. The new way just pulls pre-vetted MCP servers straight from public or internal registries, already tested and ready to plug in. For security and context, old-school agents hard-code credentials directly and bloat their context window with every tool definition. The better approach passes secrets through environment variables and loads or drops tools dynamically, so you're never diluting the model's attention. For debugging, instead of blindly tweaking prompts when the agent hallucinates, you use the MCP inspector or Chrome DevTools to audit the raw JSON RPC traffic directly. Here's a trap that quietly catches a lot of teams building on MCP, treating a genuinely collaborative agent like a passive, stateless tool. A standard tool is fire and forget. You call it once, it responds, and you're done. But the moment your specialist agent needs to ask a clarifying question, push back on ambiguous input, or negotiate scope mid-task, that simple one-shot request-response model falls apart fast. Ambiguous data and crooked assumptions pile up silently, the agent's state gets interrupted mid-workflow, and eventually it crashes. What this slide calls the GOTIO trap, borrowing from that old cautionary tale in software architecture. Agents in these open-ended domains need a real channel built in to pause, negotiate, and resume safely. That's exactly the gap. A2A, or agent-to-agent, was built to close, and it works as the lingua franca between completely different agents. Picture a Google ADK orchestrator standing on one side of a canyon and a Salesforce specialist agent standing on the other, built in a totally different framework, language, and runtime. A2A is the bridge connecting them. Despite all of that, every agent sitting on that bridge exposes an agent card, which describes its capabilities, security requirements, and interaction schemas up front, plus an executor underneath that acts purely as the translation layer between the two sides. The end result: your orchestrator can hire and collaborate with any specialist anywhere in the ecosystem, no matter how it was actually built. Once your orchestrator can talk to any agent through A2A, the obvious next question is where it actually finds them. That's the difference between the private enterprise registry, your internal, policy-controlled catalog of pre-vetted, trusted specialist agents your company already owns, versus the public marketplace, an open catalog of agents as a service running out in the wild. And when your orchestrator needs to hire an outside agent for a paid task, machine-to-machine microtransactions quietly kick in behind the scenes. A 402 payment-required response gets intercepted automatically, paid instantly with a cryptographic token, and the original request simply resumes right where it left off. No human sitting in the loop approving anything. So agents can now discover each other, connect cleanly, and even pay each other automatically. But there's still one real gap left. How do they actually show you anything meaningful? Humans naturally share insights visually. We sketch a chart, circle the trend line, point at what matters, and we're done in seconds. Agents, left to their own devices, only speak in raw data by default, a dense wall of JSON that's technically correct and completely unreadable to a human glancing at it. Constantly switching between asking an AI for insight and manually coding a front end just to display it breaks your entire vibe coding flow. We need agents to dynamically compose an interactive interface on the fly, and to do it safely, without handing over raw executable code. That safety requirement is exactly where A2UI comes in, and the model here is best understood through the sheet music analogy shown on this slide. The LLM agent never generates executable code at all. Instead, it generates a purely declarative markup describing layout and components, like a musical score describing notes rather than actually making the sound itself. That score passes through a strict boundary, labeled here as no executable code allowed, into a native renderer on the client side, which pulls only from its own trusted component catalog to physically assemble the real interface. The agent describes intent, what should visually appear on screen, and the trusted client alone decides exactly how to safely build and render it for the end user. Within A2UI, there are two distinct patterns for deciding who owns that final layout. LLM generates-UI is intent-driven. The model dynamically invents the layout straight from the user's natural language prompt, with no fixed template involved. It's great for genuinely exploratory asks like compare these regions or show me the trend, but it costs real tokens every time and needs strict schema validation with automatic retries whenever the model gets the structure wrong. Deterministic tool-based UI flips that entirely. A backend tool simply returns a fixed, hard-coded A2UI template with live data bound directly into it. Reach for this on predictable workflows like a daily dashboard or booking form. Zero UI tokens, 100% predictable output every time. Now let's put commerce into the picture with a scenario every engineer can relate to. The 2 a.m. burrito run. You tell your agent, get me a vegetarian burrito, fast. The Universal Commerce Protocol, UCP, picks that request up first, acting as the universal translator across the merchant's own machine-readable menu, correctly selecting, quote, no onions, and pulling the exact tax and delivery fee for your order. Then the Agent Payments Protocol, AP2, steps in right after, instead of ever handing over a raw credit card number. It presents an encrypted promissory note instead, tightly capped by a guardrail like, max spend $25 you set ahead of time. Once the digital signature is verified, the order executes, and your real card number stays hidden the whole time. Let's lock in the clean distinction between those two commerce protocols with a simple analogy worth remembering. UCP is essentially the ultimate food delivery app. Its core role is being the brain that decides exactly what to buy, handling discovery, product catalogs, cart management, and full order building, all unified across any business provider through one shared machine language. Think of it as the menu and the cart. AP2, on the other hand, is your parent's credit card. Its core role is purely the secure wallet, handling the handshake, payment processing, and strict financial guardrails, with a security-first focus on verifying real intent and preventing costly agent hallucinations. Think of it as the wallet and the mandate behind every purchase. Zoom all the way out, And here's the full interoperable ecosystem finally working together as one connected system. An interactive canvas built with A2UI feeds real user requests straight into your central orchestrator agent. Commerce needs flow in cleanly through UCP and AP2 on one side. The orchestrator reaches out to specialist agents over A2A whenever it needs outside expertise, and separately pulls context and live data through MCP, which connects straight down into your database layer underneath everything. Every single piece we've walked through in this video, discovery, connection, negotiation, payment, and safe rendering, all snaps cleanly into this one unified pipeline, powering a genuinely autonomous virtual workforce end-to-end. So here's the real shift sitting underneath all 5 protocols we just walked through in this video. You eliminate the ongoing technical debt of handwriting bespoke, one-off integrations for every model and tool pairing your team touches. You move from writing raw syntax line by line to actually designing the systems that let independent agents discover, negotiate with, and safely pay each other on their own. And by relying on genuinely open standards like MCP, A2A, A2UI, UCP, and AP2 instead of throwaway custom glue code, you scale infinitely without ever rewriting your integration layer again. The era of the custom-wired single-agent monolith is over. Build your harness on open protocols, and your software won't just compute, it will truly collaborate.